Hello everyone. I am Anthony M. Catindig Jr. and here is my partner, Kenneth J. Tonido. For today, we are going to create a decision tree model for our laboratory activity. In this context, the data set we are going to use is a collection of records about penguins in the Palmer Archipelago located in Antarctica. The data set contains 344 observations with 7 attributes. First, what we are going to do is we are going to import the data set. As we can see here, here is our data set. So for the attributes, we have 7 regular attributes and 344 observations. First is the species. Species are the penguin species in the Palmer Archipelago. So these are Adelie, Chinstrap, and Kentu. So those are the three. And then for the island, island stands for the island where the penguin lives. So there are also three islands. So the Torgersen, Dream, and Bisco. Then for the Kalman length, so Kalman length in millimeters stands for the upper ridge of the beak of the penguin. So it's the length in millimeters. Then for the Kalman depth is the depth of the upper ridge of the beak of the penguin, also in millimeter. Then flipper length is the length of the flippers of the penguin in millimeters. Then body mass in grams. Then the sex of the penguin, if it's a male or female. So now that we have retrieved the data, we are now going to convert the categorical variables, data from our dataset.
Now, first, we need to input a operators, which is replace. Converting categorical into numerical, which is the island or the Tergersen replaced by the zero. So you can see the data. And another replace operator. The next is for Bisco for the replace and replace by 1. And next operator, replace again. And for the dream replace by 2. Now run. And for the sex of the male is replaced by 0. And next replace operator, the sex and replace the female replaced by 1. Run. And replacing null values from the all columns. Click run and so you can see the columns of per length. Oh. Now click the design. Okay, next operator. Set role for the species into label. Now click run. So you can see the species are the Adelie, Yeah. There are three categorical traits.
So next that we are going to do is we are now going to split the data. So using the split operator, so first we are going to edit the enumeration. So we are going to add entry. First is 0.7 or 70%, then 0.3 or 30%. Then click OK, then run. So now we have only 241 examples, one special attribute, which is the species, and then 6 regular attributes. Then after splitting the data, we are now going to build our decision tree model. So we are just going to get the decision tree operator, then the model into the result. So now if we run this, it will give us this result. So as you can see, is quite big, so we are going to use the tree type to make it a little smaller. So this is the decision tree that has been made from our data set. So after building the decision tree model, we must apply now our model using apply model. Then we are just going to connect the sample set into the unlimited, and now click run. Connect the lab to the result. And so here we are. As we can see, this is the confidence level for the Adelie. So Adelie have close to 1. Then confidence level for Chinstrap and then Gentoo. So as you can see here, it made correct prediction. So we can tell that this is 100, 100, etc., etc. Then next is the performance.
Click run. So you can see our data set has the accuracy is 97.93%, which is also a good data set.
So based on the performance, we can see that our model made a great prediction. So now what we are going to do is we will try to cross-validate this model. So instead of splitting the data, we are going to use cross-validation. So first, we are just going to delete this first and remove this, then select the cross-validation operator, then connect the EXA to the sample for the cross-validation, then the model here. And if we click here, we must add first the decision tree. So we're just going to connect this first model, then we are going to select the apply, if I'm correct. Apply, then performance. So performance is classification because we are doing a classification task. Then connect this to here. Then let's go back to the design tab. Design. So we are going to connect the performance to the result. Then see. So based on the cross validation, it also gives a high accuracy, but it is quite lower than the previous one because the previous one is almost 98%, while this one is 96%. But this is still good because it still gives a high accuracy. So now we are going to bring this back to the old old model because it has a higher accuracy. So let's just control Z and here we are. So if we run this again, so this is now ready for deployment. So that's all for this activity and thank you.